Good morning, my name is Josh Rackers, and thank you for the invitation to come speak today. I'd like to tell you a little bit about what I study, the fantastic world of DNA. And you know, sometimes studying DNA gets me into a little trouble. Actually, this morning my wife and I were both getting ready. She turns to me and she says, do these genes make my butt look big? And I go, no, but they do make your eyes green. That was supposed to be funny. Anyway, I study this molecule right here, DNA, and actually what you're looking at, what you've seen probably 1,000 times before, this double helix, is not really a very good representation of what DNA actually looks like inside yours and my cells. See, here, all these hydrogen bonds connecting these two strands together, these bonds that connect the middle, they're not actually all together in the cells in your and my body. In fact, there are large segments, or there can be, that there's a bubble where those hydrogen bonds are broken, where those hydrogen bonds are separating the two strands that make DNA come together. So in my lab, we study what happens whenever you have a bubble in DNA. And to do that, we use a special technique called magnetic tweezers. And to do magnetic tweezing, what we do, we'll just leave this here. To do magnetic tweezing, what we do is we take a magnetic bead and we attach it to the top of a DNA molecule, and then we pull on that bead. And using a very high-powered microscope and some powerful magnets, we can watch what happens to that bead and know what's happening to the DNA molecule it's attached to. So how this works for a regular DNA molecule is actually pretty well understood. Whenever you pull on the bead, it acts like a pendulum, knocks back and forth. We already know that, and we wanted to know what happens whenever you put a bubble in DNA. And you might think this would be pretty complicated, but it turns out that this is just as simple as putting a hinge in that DNA molecule. And whenever you knock that hinge, that motion can almost perfectly describe what happens to a DNA molecule that has a bubble inside of it. Now this is amazing. It's amazing for two reasons. Two reasons that, one that's just cool and another one that means a lot to you and I. The first reason is that we've been able to take a single DNA molecule, one double helix like this, attach a little tiny bead to the top of it, and just by watching that bead, we can tell what's happening with that DNA molecule that it's attached to. That's neat. But even if you don't care about how neat or cool the physics of it is, you have to appreciate that DNA flexibility makes a big difference in our lives. DNA needs to be flexible in order to replicate DNA to make new cells. DNA needs to be flexible to repair mismatches, to avoid cancer in yours and my genome. And so not only is it cool, it's something that gives us this little tiny window, but clear window, into the fantastic world of DNA that makes you, you, and me, me. Thank you.